at surface area and volume of composite figures. So I want to introduce you to the surface area and volume of different shapes. This time we're going to look at pyramids and cones. So the shape here is an example of a pyramid. And pyramids are actually named using the shape of the base. Now this word apex, that represents the point where all the triangular faces actually converge or meet. Right there, right at the top. Now the height of the pyramid, yes, is the perpendicular distance. You see how it's perpendicular, this right angle here? It's perpendicular distance from the apex to the actual center of the base. So here's our height to the center of the base. And the height on the triangular face is often called the slant height. So I'm going to write this down as slant height. And I want you to also label that on the diagram. That would be this height here on the face of the triangle. That, my friends, slant height. So whenever I ask you to find the surface area of a pyramid, I really want you to actually draw a net first. Okay, so a net, once again, think of a banana. When you're peeling banana and you're squishing it down, that's the net. Now if I look at this one here, I guess there should be A and B. I look at this and I see the base happens to be a square, so I'm going to draw that base first, and it's 4 millimeters. And then we have triangles, right? We have 1 triangle, 2 triangles, 3 triangles, and 4 triangles that when I unravel it look like this. And each of the triangles has once again a base of 4 and the height here of 2.1. Now the height here is in reference to the actual height of the pyramid, which might be a problem for us because when I'm looking at the triangles, I need the actual, I'll use this color green, the perpendicular height here, or the slanted height. So I think one of the first things we need to do is actually calculate the slanted height on the side of a triangle. And hopefully you can see that to do so, I'm going to use this right angle triangle. And because it's a right angle triangle, yes, 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 Pythagoras to the rescue. So I'm going to call S here the slanted height, and that's what I want to find out. I know that the actual height of this triangle is 2.1, and the base is half of the length of 4, which is 2. So using Pythagoras, 2 squared plus 2.1 squared equals to S squared. I know 2 squared is 4, 2.21 squared is 4.41, that's equal to S squared. 8.41 equals S squared. If I take the square root, I'm doing this in my head, but if you can use a calculator, that works too. It's actually 2.9. That's great, because now what you've told me is that each of these triangles has a slanted height here of 2.9. Cool. So how do we actually find the surface area then? Yeah, we'll take the area of all the pieces. So the surface area, I'll call SA, equals to, how about the area of the base plus, plus the 4 triangles. And so the area of the base, I'm so thankful it's a square, so 4 times 4. And then the areas of each of the triangles here, well, the area of a triangle is the base, which is 4, times the height, which is 2.9. And we're going to divide each of them by, that's right, 2. And if you do this properly, let's see, 4 times 4, that's 16. 4 times 2, I don't know, I'm going to use a calculator for this one. Let's take a look. 4 times 4 times, 4 times 2.9 divided by 2. Lo and behold, 23.2. And if I add them together, I get 39.2. Don't forget our units, millimeters squared. And there you have it. The surface area of this pyramid. Okay? Now, it's the same idea for part B. So let me draw the net. This time it's no longer a square. That base, it says it's a regular polygon. That's good, it's regular, but notice the base here seems to be 5-sided, and a 5-sided base must be a, you got that right, pentagon. Right. Interestingly enough, since this is a regular pentagon, actually 5 equal triangles make up the base of the pentagon. And then of course we have the sides that are also triangles. 1, 2, 3, 4, 5. And thankfully for those, this one looks kind of weird. I'll draw this again. Thankfully for each of these, they gave you the slanted height, which is 8. We know the base of each triangle, that's 4.4. And so finding the area of the triangles, which are the sides, are pretty straightforward. The tricky part about this one is actually finding the area of the base, which is the pentagon. But did you hear what I said? I said that they're all, oops. Let's go back. But did you hear what I said? I said the triangles here all have the same height and the same base. So the height of each of these triangles here is 2.3, and the base of each of these is also 4.4. So how would I go about finding the surface area in this case? Once again, it's the area of the base. And the area of the base is really the 5 blue triangles, plus the sides, the 5 sides, which of course are the 5 green triangles in this case. Okay, so how can we find the surface area then? Well, looking at the blue triangles, each triangle has a base of 4.4 and has a height of 2.3, and to divide that by 2 to find the area of one triangle, and then don't forget to multiply it by 5 because there are 5 of them. Similarly with the sides, the green triangles, the base is 4.4, the height is 8, divide that by 2, and then don't forget there are 5 of those as well, so we'll multiply that by 5. We'll go ahead and do all the calculations here. The one in blue, I think that's, what is that, I think it's 25.3. Double check my calculations with what you have done on the calculator. This other one, I think it's 88. So 25.3 plus 88 gives us a lovely answer of 113.3, in this case, meters squared. And that's how we can find this surface area. Now, it's nice to do, but can you come up with a general way to find the surface area of any pyramid where the base is a regular polygon? And if you said, yeah, all we need to do is just find the area of the base, and then add it to what? And add it to, yeah, those sides, and those sides all happen to be triangular faces, so add it to the area of all the triangular faces on the side. And that's how you can find the area of a pyramid. Cool. So turn the page with me, and now I'd like to actually show you with we can create a formula that actually describes the surface area of any pyramid with the regular polygon base. So to do so, I'm going to look at this right square pyramid. Okay, I'm going to use L to represent the length of each side of the square. So length of side of square, and then S will represent the slanted height. Okay, So like what you said earlier, the surface area is just the base area plus all the lateral or all the triangular faces. The lateral just means the side pieces, okay? So all the triangular side pieces. So if I want to do this here, the base in this case is L squared. And the lateral triangular faces, the area has to be, well, there are 4 of them first of all, yeah. And then each of them have a base of L, right? L. We're multiplying that by the height, which is the slanted height S, and we're divided by 2. Okay. Now, I'm just going to rearrange that expression in the second part of this equation. I'm going to take out the 1/2, and I'm going to stick the 4 inside, because I can move the division and multiplication in this way. It won't change the actual value of my expression. So this becomes 4L, and then I'm going to times that by S. Now, you're thinking, why would I even do that? Well, the reason is I want us to see what this 4L actually represents. What is 4L? Here's 1L, here's 2L's, here's 3L's, here's 4L's. 4L's is equivalent to, yeah, the perimeter of the square. So this actually represents the perimeter of the square. And the square just happens to be the base. So this gives rise to this idea, that the surface area of a right pyramid with a regular polygon base is actually equal to the base area, we got that, plus, and I'm going to use this expression now, plus what? Plus half times the, yeah, that's the perimeter of the polygon base times S, that's right, the slanted height. And this gives rise to a nicer formula that you might want to memorize, you might not, it's up to you. But here's another way to find the surface area of a right pyramid. Okay, base area plus half the perimeter times the slanted height. So knowing this, let's quickly find the answers to example number 2 using this formula. So nice, once again, a nice regular polygon base. So the surface area equals to the base area, which would be 8 times 8, plus half of the perimeter. The perimeter would be 4 of these 8s, right? 4 times 8. And then multiplied by the slanted height, 12.3. And you can do this on your calculator. I think this is 196.8. And so your final answer, 260.8. And don't forget your units, millimeters squared. Okay? Alright, try part B yourself, but notice this time the 25 is the, not the slanted height, but the edge of the triangle. Uh-oh. So maybe I'll help you with this part first. We have to find the actual slanted height. Hopefully you can see the whole thing is 14, so this part here is just 7, and I can visualize myself with a lovely right triangle like this. 7, slanted height 25. Hello, Pythagoras. Pythagoras to the rescue. 49 plus s squared equals 625. S squared equals to 576. S equals to 24. Yes, 24. A nice number. Okay. Now, if you're thinking, is that all I need? Well, I think there's one more thing I need to help you with, because the area of the base, since this is a hexagon, 6 sides, 1, 2, 3, 4, 5, 6. Notice we get that by making 6 triangles. So perhaps each one of these triangles here, I'll quickly help you find the area of that, because this is 14, this is 14. I need the height of this triangle as well. So hello Pythagoras again, this time using 7. So I'll quickly do that here. 7 squared plus this height, I'll just call h. H squared equals to 14 squared. Pythagoras again. Oh, look at that. Pythagoras always coming back. Always coming back. In this case, it's a nice decimal, or not so nice decimal. I'll just round this to 12.12. Okay? Now, I think I've given you all the numbers that you need now. Can you now try to find the surface area yourself? I'll ask you to press pause, then come back and check your work with mine. So the base, that's those 6 triangles that make up the hexagon. So 6 triangles, the area of the triangle 14 times the height 12.12 divided by 2. There's your base area. Plus, that's right, half of the perimeter times the slanted height. So the perimeter would be 14 times 6. That's the perimeter of the base. And the slanted height is 24. So if you do all these calculations on your calculator, I got 509.04. Add to that 1,008. A whopping 1,517.04 inches squared. And if you got that, give yourself a pat on the back. Yay! Alright, so moving on. Hey. What do you think happens if I actually were to increase the number of sides of the base? Increase the number of sides of the base. The idea here is then the number of sides approach something called infinity, also known in math as the limit of the base is equal to infinity. Now, this idea of limit, you'll see that when you start taking calculus, hopefully in grade 12. So, yes, in your Math 9 course, I've already hinted to you that, hey, you can understand one of these concepts that we do in calculus. So I hope you can visualize what happens when the number of sides of the base polygon increases. This one had 4, right? Start with 4 sides. Then we have what? 6 sides. Then we have more sides. And then think about what shape you'd actually get if you have an infinite number of really tiny sides. Well, that base actually becomes a circle, right? And then if I have a circle, you actually create a cone. So you actually get a cone. Yay! So this idea of the limit of the base to infinity is this notation here, lim, as b approach to infinity. And so if I applied our surface area formula, let's see if we can now calculate the surface area of a cone. So a surface area of a cone is defined as the base area, once again, plus 1/2 of the perimeter of the base times slanted height. Well, in this case, what is the base area? It's a cone, right? The area of a base of a cone, that shape must be a circle. So what's the area of the circle? That's right, pi r squared. Okay, plus 1/2 what? Oh, the perimeter of a circle. Well, that just represents the circumference. Do you remember the formula for circumference? Yeah, 2 pi r, very good. And our slanted height is still going to be called s. I really should label this as r. So we have this, and now if I were to simplify the formula, look at what we get. Pi r squared, the half times 2 is just 1, plus pi r s. And this is the formula for the surface area of a cone. It really comes from the idea that the area of any pyramid, and if you can think about it, a cone is just a special pyramid. The surface area is equal to the base area plus half of the perimeter of the base times the slanted height. Okay? So knowing this, can you go ahead and try to find the surface area of the following cones? And I'm going to ask you to leave your answers in terms of pi, so you don't have to have these crazy long decimals. Okay? But if you do want to round, then round to 2 decimal places. So, looking at A, surface area, pi r 17 squared plus pi r, once again 17, times s, 21. So 289 pi's plus 357 pi's is equal to 646 pi's, and then once again our units, centimeters squared. So this is actually the mathematician's preferred answer because it's accurate, it's not rounded. But if you actually do want to round it, then you can use your calculator and just type in 646 times 3.14159 blah 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 blah, and I would actually use the entire decimal that's in the calculator button that's called pi instead of just using 3.14. And then you'll get an answer like this, 2029.47. That's perfectly fine as well. Okay? Alright. Go ahead, please, and you try part B. And if you actually multiply this out, 2,997, that's what I meant to say, 0.08 feet squared. Either or will make me happy. Reminder once again here that 36 represents the diameter, so half of it must be the radius. Okay. Woo! So, our continuation here, we've done surface area. Now, we can try to find volume. And if you're thinking about how do I find volume, or what's the definition of volume? Well, remember, the volume is really just the amount of space in the object. And if I ask you to figure out how to find the volume of a right prism, it's really the base area multiplied by the height. Now the base could be any base, but it's more important to say this. I like to write down the word uniform base. So the base has to be the same as you move throughout the height. If it actually changes the shape of the base as the height changes, as you move up the height, that is a problem. So for number 4, yeah, you can choose the base area as the shaded part here, which would be 5 times 2. And then in this case, the height would be 7. And you can find that as the volume. That works. Or if you did it this way, where you called this the base down here, so 7 times 2, and then you called the height 5, that's okay once again, because the base is the same as you move up the height. That also works. So in this case, there's many different ways to do it. Nonetheless, you're just taking those 3 numbers and multiplying together, just like how you learned it in Math 8. So I think the answer here is just 70 inches cubed. I do that with you because part B, I can't use this bottom here as the base. Because can you see as I move up the height, the base seems to get larger and larger and larger and larger. So that's why I put in the word uniform. And so I would actually treat this shaded area as the base area. And the base area of this shape is actually a trapezoid. Don't know if you remember how to find the area of a trapezoid, but you find the average of the 2 sides that are parallel, so the 8 and the 6. Sorry, we find the average, which would be 8 plus 6 divided by 2, and we multiply that by the actual height, which is 5. So the base area in this question is just 35 centimeters squared. And now once we have that base area, I can ask you what number here represents the height. So now as we go out and create this 3D shape, I hope you can see that the height is actually 7 centimeters. So the volume would be 35 times 7, and that equals to 245 centimeters cubed. Okay, cubed. Now, that's a good review of hopefully volume, but now I want to actually find out the volume of these pyramids and cones. Okay, so I want to see what relationship holds between the volume of a regular prism and the volume of a pyramid with the same base and the same area. Okay, and to do this, I'm going to see if I can get you a video to see. Alright, hold on. Once again, pyramid and the prism, same base. Okay, there's one of those filled up. That's 2. That is 3. Okay, so what's your conclusion here? The volume of the right prism is actually equal to how many of the pyramids? Did you say 3? I hope you did, because that's what I saw. So 3. So therefore the volume of the right pyramid is actually not 3 times, but 1/3 of the volume of the right prism. So if the formula of a right prism is really just the area times the height, then the volume of the right pyramid would be 1/3 times the base area multiplied by the height. And there you go. That's how we can find the volume of a right pyramid. It's really just the base area times the height, but make it 1/3. So for 5a now, if I look at this shape that we've done before, this will be 1/3 times the base area, which would be 8 squared, multiplied by the height. Uh-oh. Be careful what height we're talking about here. The height that we're talking about, no, it's not the slanted height, but the actual height to the center of the base. Oh no. I guess I need Pythagoras again. Oh. I'll quickly do it for you. 12.3. This is height, and the base here equals to 4. 4 squared plus 8 squared equals to 12.3 squared. We've done this so many times that I can kind of skip a few steps, I think. And then I'll just tell you that h is the square root of that, or 11.6. So therefore I should multiply it by the actual height of 11.6. And when you do this, you'll get the lovely answer of 247.5 millimeters cubed. Once again, 1/3 base area times height. Same idea here once again. I think we actually found the base area before, but if we forgot how to do that again, it's those 6 triangles here. I'm actually going to go back up and steal the answer. What was the answer from before? Whee! Oh yeah, right here. Okay, that's 509.04. Okay, so 509.04, or I'll even say this. I believe we found this height here to be, I think, 12.12. So volume, once again, 1/3 base area. So the base area is just those 6 triangles that make up the base, with base 14, height 12.12, divided by 2. And in this case, the height of the actual pyramid going to the center of the base, that's 30, so we can do that. And if I did the calculations correctly, and you can double check it with your calculator, I got 5,092 inches cubed. Okay? Nice. Alright, last page. Hey, what about the connection between a cylinder and a cone? So let's take a look at this video to check it out. Oops, I made it double speed, by the way, so we can get through.
Demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height.
Same diameter, same height.
The cylinder is filled exactly with 3 full cones of water.
How many full? Let's see. look at that. It's also 3.
The volume of the cone is a third of the volume of the cylinder.
Volume of a cylinder, 3 of the volume of the cones, or the volume of the cone once again is 1/3 the volume of the cylinder. Now I don't know if you remember the volume of the cylinder formula, but it's always just the base area, in this case pi r squared times the height. So therefore the volume of the cone just happens to be 1/3 of that, yes, pi r squared times the height. And so now to finish off this long lesson, I'm sorry it was long, but I thought it was worthwhile to show you how these formulas came about instead of just telling you what they are. Notice that for part 6a, I'm going to ask you to find the volume, and we need the actual height, so good old Pythagoras to the rescue again. Are you sick of Pythagoras yet? I know we've been using it quite a bit. 12.33, I think it is. So therefore, the volume of this cone is 1/3 times pi times r, which is 17 squared, multiplied by the actual height, 12.33, and I got actually 1187.79 pi centimeters cubed, or if you multiply that by pi, so 3.14159, blah, 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 I got this number, 3,731 centimeters cubed. Okay. And then for part B, I think it's very similar, so I'm going to leave that for you to try, and then once again, double check your answer with me. Alright? You know the drill. Press pause, do it, then come back and check. Radius 18. Oh, I do need the height though. Oh no. So notice I got 35, 18. I need the height again. Pythagoras. I thought I wouldn't have to use you, but nope, I gotta use you again. I think that's 901, so volume equals to 1/3 pi r, which is 18 squared, times 30.02. And if you got that, you should be very happy, because that's what I got too. And if you can get the correct decimal representation, you should be extremely happy, because you know how to use the calculator like me too. Alright, that is it.